Today we're going to be talking about section 8.2, ellipses and hyperbolas, the last two of our conic sections for consideration in this chapter. First of all, hopefully you're looking at your handout that I posted on the Lessons tab. Notice the definition of the ellipse is a set of all points in a plane, the sum of whose distances from two fixed points is constant. So if you look at that picture below where you have a focus in red and another focus in red, and a point P, those dotted lines are the distances from each focus to that point, and no matter where that point is, the sum of those two distances will be a constant. Those 2 points are called a focus, and those fixed points, kind of like the center of a circle, don't change, and the point's location is determined by some sort of distance from that. In this case, those 2 points. Notice that the graph of an ellipse is not a function. It is a symmetric figure. As seen there, you've got a major axis, which goes from one vertex to the other, called major because it's the longer of the two axes. And the minor axis is the shorter distance from, in this picture, from the bottom point to the top point of the ellipse. Now, if the ellipse happens to be oriented this way, the major axis is vertical. So this is the major axis right here in blue. Sorry for the messy drawing. And the minor axis I've drawn there in that fuchsia color. These two lines or axes of symmetry intersect at what's called the center. And as we've seen before, we'll use HK for this special point, just like we did for the center of the circle. The center of the ellipse, where the two axes meet, is going to be called HK. All right. And you can read in the next page or so the development of how you take the sum of those two distances. I'm sorry, I'm not sure I actually included that. I think I did, but I'm not sure in your version of this. But at any rate, if it's there or it's also in the book laid out, and you want to read through how the sum of those two distances is equal to 2a, the length of the major axis, and how they derive the formula, that's great. I don't need for you to be able to reproduce that thought process, so don't worry about it at all. And they derive an equation for the ellipse centered at the origin. And I'm going to go ahead and skip to where the center is off of the origin, or perhaps off of the origin. And this is what the equation will look like. X minus h quantity squared divided by r sub x squared, I'll define that in a second, plus the quantity y minus k squared divided by r sub y squared equals 1. The r sub x is what I call the x radius. So that means going from the center in the x direction, left and right. That's the distance you're going to be moving. In the x direction, left and right, for the r of x, that'll be the distance that you move left and right. Notice you'll have to take the square root of that number to get that distance. R sub y, by the same logic, is the y radius, and it's the direction from the center that you move up and down to get to those major points that are on the ellipse. So in the book, they will sometimes call r sub x a, sometimes they'll call r sub x b, and in order to avoid that confusion, I'm calling them the x radius and the y radius. There's nothing wrong with the a and the b. It's just, this is a one answer equation to what is the equation of an ellipse. There's some reason to know what A and B are, and I'll get back to that in a second. But for our purposes, I think it's really fine if you leave it as r sub x and r sub y. All right, so as it turns out, if we were to measure the distance from the center to the vertex, that distance would be A. If we were to measure the distance from the center to the endpoint of the minor axis, that would be B. And so you notice in this particular picture, A is R sub X and B is R sub Y. Whoops, hold on. Let me change my colors here. And if you have one that looks like this, your A goes from the center to the vertex, and that's A. In this case, A is the R sub Y. So using mine, R sub X always means how far you're going in the X direction, and R sub Y always means how far you're going in the Y direction. Here you notice A could be the X direction distance, or it could be the Y direction distance. And so that's why they end up having two formulas for this, which I believe is unnecessary. All right, at any rate, there's one more segment I'd like to put in both of these drawings. If you measure from the center to a focus, and of course these drawings are very sketchy, not perfect, so don't worry too much about whether I'm drawing it exactly the right place. I'm probably not. Those are what we're going to call the major distances, the X radius, Y radius, and focal length. That's what C is. C is the focal length. The length, or the distance from the center to a focus. And because of symmetry, you can draw these lengths on either side. I'm tending to go right and up. You could have gone left and down instead, and it wouldn't change anything. Just this seems like an easier way for most people to deal with it. All right. So if we were to take, let's say the left-hand one where it's the major axis from vertex to vertex is horizontal, the first picture. If I were to take the distance C, let's just pretend like this is exactly what C is there. I'm trying to copy it without worrying about perfection. Thank you for agreeing to let me do that. And B, you'll notice that those two things are perpendicular to each other. And as it turns out, the length of A is always going to be exactly just right to form a right triangle. And because of the Pythagorean theorem, we know that leg squared plus leg squared equals the square of the hypotenuse. And I'm glad I didn't rely on A squared plus B squared equals C squared here, because that implies that C is the hypotenuse, which is obviously not the case here. At any rate, one of the problems you'll be dealing with is finding that focal length so that you can find the coordinates of the foci. So I would like for you to solve that equation I just got from the Pythagorean theorem for C squared, which will involve subtracting B squared from both sides. And that is an equation that you'll need to memorize for ellipses, that when we're trying to find the focal length, it'll be A squared minus B squared to get C squared. Now, as it turns out, you may worry about, well, you're calling this R sub X and R sub Y, and which one is which in each problem? Well, I'll tell you, it really doesn't matter in the long run, because as it turns out, A has to be greater than B here. A has to be the larger radius of the two, because the hypotenuse of a triangle is, of course, longer than any leg. And the major axis is longer than the minor axis, so the major axis half length A will be longer than the minor axis half length B. Because of that, look down at this equation I said you need to memorize. If you take a large number squared minus a smaller number squared, you're going to get a positive answer. You'll say C squared equals a positive number. I can take the square root and get an answer. If you accidentally thought that the reverse was true and you accidentally did small number squared minus larger number squared, like 2 squared minus 3 squared, 4 minus 9 is negative 5, C squared equaling a negative number doesn't work, and so you may at that point realize, oops, I got them switched. I just need to reverse my subtraction to get this right. So I don't think you're in danger of losing which one's which because you're subtracting, and you don't want c squared to be negative. All right, so I'm skipping around a little bit in my notes. They really talk a lot about where it's centered at the origin and develop the equations, and then later they develop it with the center elsewhere. And I'm just not going to go through all that. I'm going to skip right to what you need to know. And so the equation I wrote above and the equation I boxed for finding c, those are the things that I would suggest that you learn. Those are the things that are most important. So let me, oops, I went too far. Let me highlight again the things that you're going to need to memorize. And of course, any of the pieces of that, you'll need to know what those symbols mean, like what does r sub x mean and what does r sub y mean. But this formula for the equation of an ellipse, this is a standard form of the equation of ellipse. This is something you need to know. Before I go away from it, you might notice that it is fraction plus fraction equals 1. And that's an important part of writing the equation in standard form, is it's got to be in the form fraction plus fraction equals 1. All right, so, and then of course memorize the c squared equation that I talked about earlier. So skipping a little bit, let's go to some examples. Some of these will start out with center at the origin because I didn't develop it for everything at first, but that's fine. Let's just do the problems as stated and see what we get. Okay, so problem A is 4x squared plus 9y squared equals 36. All right, so the very first thing I would do with this equation is I would realize that it's an ellipse. You can tell that, by the way. Let me think about this with you for a second. For a circle, the coefficients of x squared and y squared were the same number. For a parabola, only x was squared or only y was squared and the other variable was not squared. That's for a parabola. For an ellipse, the coefficients of x squared and y squared will both be positive or both be negative. We, of course, would want to treat them as positives eventually, but it can start out as both negatives. But there'll be different numbers. Like here, the coefficient of x squared is 4 and the coefficient of y squared is 9. They have the same sign, they're both positive, and different numbers. That is an indicator that this is an ellipse. All right, so since it's an ellipse, I want to get it in that standard form. And I know that one of the things about it is that it's something plus something equals 1. And I have a sum of things on the left side, but I don't have it equal to 1 on the right side. So to make that work out correctly, I'm going to divide both sides of the equation by 36, which means I'm going to divide each term individually by 36. That's going to turn that right side into equals 1. Now, simplifying, 4 and 36 cancel, leaving 9 in the denominator. And 9 and 36 cancel, leaving 4 in the denominator, equals 1. Now this is a pretty standard textbook example where they made it such that the coefficients 4 and 9 multiply to be 36. And so it appears that, oh, all you have to do is switch the coefficient to the other fraction's denominator. Well, it looks like that happens on the first few examples, but in fact, that's not a thing. And so you need to actually divide by the number to turn it into 1 and then simplify. And it may very well often be that those coefficients appear to go underneath in the denominator of the other variable's fraction, but that's not a thing. So please don't think it's always going to be true. All right, so if you look at this equation and think about the boxed equation up above, the standard form for the ellipse, the center, what would you subtract from x and then square it to get x squared? Well, of course, the answer is 0. So when you see just x squared or just y squared, h and k would then be 0. You'll get used to seeing that a lot, so no worries. Then the next thing I would find is the x radius. So look in the x fraction and take the square root of the number underneath x squared, and so the x radius is 3. Likewise, the y radius is the square root of the number underneath y squared, which is 2. So, let's see. Move this down a bit so we can get... Now, c squared is going to be a squared. Which of those is bigger, 3 or 2? Well, obviously 3 is bigger, so that'll be the bigger number first. 3 squared minus 2 squared. C squared, therefore, is equal to 9 minus 4 is 5. So C is equal to the square root of 5. All right, so let's graph. This is the thing that you can do from standard form usually very easily is set up the graph. Once you've identified the center and the x and y radii, then you're good to go. All right, so our center is at 0, 0. Let me put a great big dot there so you can kind of see it. And I forgot to put a scale here. Let me do that as well. I'm going to assume that these are all marked by 1s unless marked otherwise. So hopefully that's okay with you as well. All right, so the center is at 0, 0. Then the x radius is 3. So I'm going to move from the center, 0, 0, right 3, and left 3. The y radius is 2, so I'm going to move from the center up 2 and down 2. Then we're going to connect those 4 points, just like we did with the circle, with a curve, but this time the curve is going to be sort of an elliptical shape instead of a circular shape. It's still a curve. Make sure you're not drawing straight things between these points. It's a curve, and it takes some practice to get any good at drawing these. I still mess up sometimes, especially on this new graphics tablet I'm trying to do this on. So that doesn't look too bad. I'll take it. All right, so one of the questions is always going to be that you should find the foci. So let's find those. One thing to keep in mind is that the foci are on the major axis. So the vertices and the foci and the center, those 5 points are all on the same line, and they're all collinear. And so that will always be determined by the longer distance. So since we went further in the x direction, that means that the vertices are actually out here to the right and left. So here's a vertex and here's a vertex, which you don't need to label that way. I'm just showing you that the longer distance takes you to the vertices. And what that means is that the foci are found by going in the same direction. So when you go from the center left and right to get there, you're going to be changing only the x coordinates, not the y coordinates. So you're going to start out at 0, 0, and to the x coordinate add square root of 5 to move to the right of 0, square root of 5, and then from 0 subtract square root of 5 to move left square root of 5 from 0. And of course the y coordinate won't change. And so that would simplify to be plus or minus the square root of 5, comma 0. If any of these points that I ask you to find involve radicals and you end up having a plus or minus in there, you do not need to write it as 2 separate points. This could be written as square root of 5, comma 0, and then negative square root of 5, comma 0. But when you have a radical expression with a plus or minus in front, you may leave it as a combined thing. This is actually 2 points in one ordered pair because of the plus or minus. So They might ask you for the vertices, so I'm going to go ahead and write that here, although in this problem it was not requested. It is something you should be able to find. And using the same thought process, we went in the x direction further, and so that's going to take us to the vertices. So we're going to start at 0, 0, and because we moved in the x direction, we're going to add and subtract our bigger radius. In this case it was 3. Add and subtract 3 from the x coordinate of the center, and that gives you plus or minus 3 comma 0. Now what I just did was sort of formulaic, and I'm not sure that that's really going to help you that much. What I would do is just note that the vertices are further from the center than the other 2 points that you graphed, and then just look at your graph and see where the coordinates are. It's really easy to say that the one on the right is at 3, 0, and the one on the left is at negative 3, 0, which is of course what I was getting to before. One thing is, if the plus or minus is followed by a number that's not a radical number, I would expect you to separate it into 2 points, as I did here. All right. So anyway, that's how you find the foci and vertices. Then they ask us to find the domain and range. So the smallest x used is negative 3. The largest x used is positive 3. The range, the smallest y value used is negative 2. The largest y value used is positive 2. And so those are our domains and ranges. All right. All right, so let's go to another problem. Move this down a little bit more. Okay, on this next one, I'm not going to necessarily write down the vertices since we practiced that. That will be a thing on many of the problems, but I'm going to follow the directions this time. All right, so 4x squared plus y squared equals 64. So the first thing I'm thinking about is I know it's an ellipse because 4 and 1 have the same sign, coefficients of x squared and y squared, and they're different numbers, so that tells me it's an ellipse. And I have a sum that equals 64. I want it to equal 1 for the equation of an ellipse, so I'm going to divide both sides of the equation by 64, meaning I divide every term by 64, and simplify. So the 4 and the 64 cancel, leaving 16. And the second fraction is already simplified, y squared over 64. Oh, by the way, if it divides out and that becomes a 1, like y squared over 1, if that had happened, then I do want to see a fraction there because that tells me that you know that the distance, it would be the square root of 1, which would be 1. So even if it becomes y squared over 1, I don't want you to change that into plain y squared in this arena because it's informative about the graph. So I wouldn't want to see that you do that. All right, so first thing we're going to identify once we have the equation in standard form is the center here is at 0, 0, like last time. Oh, and by the way, did you notice that the coefficients of x squared and y squared didn't just switch like they did in the last problem? So this is a good example of go ahead and do the division and simplify. Don't rely on some kind of trick like switch the numbers to the other variable and put it in the denominator or something like that. I know a lot of people think that that's true after a couple of examples, but please don't go there. All right, so what would the x radius be? Well, the square root of 16 is 4, so that's the x radius. The y radius is square root of 64 is 8. So c squared is equal to larger number of those two that we just found squared minus the smaller one squared. And so 64 minus 16 is 48. And so C is the square root of 48. 48 is 16 times 3, so that simplifies to be 4 square roots of 3. All right, so now I think we're ready to graph. And you notice I'm graphing before I find the foci and all that stuff, because the graph actually helps inform me about, you know, which way am I moving and how far am I moving, and which one is the longer distance. And that will help you determine which way you're moving for the foci. Sorry, this takes a little bit of time. Alrighty. So since our center is at 0, 0, I'm going to put a dot there. I know you can barely see that, but I'm thinking of putting a dot there at any rate. Then the x radius is 4, so from the center I'm going to move 4 to the right, 4 to the left from the center. And the y radius is 8, so from the center I'm going to move up 8, 1, 2, 3, 4, 5, 6, 7, yeah, I did count that many. Up 8 and down 8. Then draw your ellipse as a curve that looks ovally, not like a diamond, but more curvy than that. And as I said, this takes some practice. I'm still not getting very good at this, so oh well. It's fine. All right, so the coordinates of the foci. This time we moved from the center up and down further than we'd moved left and right. So starting at the center, 0, 0, we're going to move up and down a distance c to get to the foci. So since we're moving up and down, that's going to change the y coordinate by 4 square roots of 3. So we're going to add and subtract 4 square roots of 3 to move up and down, respectively, from the center, the focal length distance. And so we get, excuse me, there we go, we get 0, comma, plus or minus 4 square roots of 3 are the coordinates of the foci. There we go. All right. And then I believe this one also asks us to find the domain and range. Actually, a really easy question. After you've gotten the graph done, no big deal. So we go from -4 to 4 for our x values. So that's our domain. And the range, we go from -8 to 8. Wonderful. So given an equation we've been graphing, now we're going to reverse that, and I'm going to give you information about a graph, some of the information that we found about this equation and helped us get the graph. We're going to reverse this and, given that information, find the equation. So this one, we're told that the center is at the origin. So the first thing I do always is I sort of make a really quick graph of what I'm given. And it says that the foci are at 0, 3, and 0, -3. You may have noticed that I didn't, on those earlier graphs, I didn't necessarily plot the foci. I'll be looking for the coordinates to be correct. If you want to plot them, it doesn't hurt a thing, but I usually don't. All right, so with the foci 0 plus or minus 3, that tells us that we're going up and down for our foci, and our center being at 0, 0. Remember I told you that the major axis contains the 5 major points, the 2 foci and the center. So our larger number is going to be r sub y. R sub y, because of this information, because we're going up and down, we know that r sub y will be the greater of the 2 radii. All right, then they tell us that the major axis is length 8. So if the major axis is 8 long, half of that is 4, and so that means it will be going up 4 and down 4 to get to the vertices. Okay, so that implies that our r sub y is 4. It's kind of like those questions you had as a kid where they tricked you and gave you the diameter, but the formula used radius, so you had to remember to divide by 2. So when they give you the major axis length, the radius is half of that, so make sure that you don't forget to divide by 2. C squared is the next thing I would like to address in this problem. Recalling that c squared is a squared minus b squared is really helpful. Because our foci are at, well, one of them is at 0, 3, that means that c is 3. So c is 3, so I'm going to put that into the equation. And r sub y is 4. We know 4 is the bigger one. R sub y is the larger one. So that means I'm going to put 4 in for a, because it has to be larger. 4 squared minus b squared. And then if I add b squared to both sides and subtract 3 squared from both sides, I have solved for b squared. And 16 minus 9 is 7. You might notice I didn't solve for b because I don't need it, because the equation has the radius squared each time, and b squared is what would go into my equation, which in this case that's r sub x squared, as it turns out, because b is the shorter distance, and we already determined that r sub x is the shorter one. So this is the r sub x that's being squared right there. Okay, so what's our equation? Well, because the center is at 0, 0, it's going to be x minus 0 quantity squared over r sub x squared, which is 7, plus y minus 0, because the center is at 0, 0, y minus 0 quantity squared over r sub y squared, 4 squared is 16, equals 1. Okay? So if we were plotting this in its entirety, do you know what the square root of 7 is? Well, I know it's less than the square root of 9, which is 3, but bigger than square root of 4, which is 2. So it's somewhere between 2 and 3. So I'm going to guess that it's about right there. That's square root of 7, and that's square root of 7. And by the way, you don't actually have to complete this graph. This is just a thinking piece to sort of make sure you're going the right direction each time. And it will also help with the domain and range question. So if you look at this one, the domain will be, we're going from negative square root of 7 to square root of 7. And our range is negative 4 to 4. And again, I'm relying on my graph to help me figure that out each time. All right. So the next page actually gets to the point where I was already, where h and k are not necessarily 0, 0. And so you can see those equations. They're finally to the same point we were at. And on the very next page is the one that I asked you to memorize, the one that uses r sub x and r sub y. So that's the one that I really want you to know, plus the equations c squared is equal to a squared minus b squared. Okay, so now that we've established that and we're good to go, I'm ready to go to the next example. So let me move down a bit. It's a very slow process on this computer to move down. I know I could go a page at a time, but that goes a little bit too fast, unfortunately. So, at any rate, the next problem has us looking at the equation x minus 2 quantity squared divided by 9 plus y plus 1 quantity squared divided by 16 equals 1. All right, so this one is actually, because of the form it's in, fraction plus fraction equals 1, we know that this is an ellipse because it's in that standard form. And we're actually ready to just start finding information so that we can graph it. The center of this one is at positive 2. Remember, you look for the opposite of the number you see, comma, negative 1. That's the center. R sub x is the square root of the number underneath the x squared term, so that's 3. R sub y is the square root of the number under the y squared term, so that's 4. C squared will equal the larger number squared minus the smaller number squared. And when I'm talking about these two numbers, those are the radii that we identified in the prior step. 16 minus 9 is 7, and so C is equal to the square root of 7. Actually, this one doesn't ask us to find the foci, so although I just did that, it didn't ask us to do that, so I'm not going to actually go there. I'm not going to worry about that, so just ignore that, although sometimes that is needed. This problem doesn't ask for it, so I'm just not going to do it. Okay, sorry about that late minute adjustment. Okay, so I've got the x-axis and the y-axis. We've got a center that's at 2, negative 1. And thinking ahead, the x radius is 3, so from that center I'm going to have to be able to go 3 to the right, and 1, 2, 3 to the left. And from the center, the y radius is 4, so I'm going to have to go from that center point up 1, 2, 3, 4, and from that center point down 1, 2, 3, 4. And that'll help you get your axes all set up nicely with the right scale and all that. All right, so from the center we're moving right 3 and left 3, up 4 from the center and down 4. And then do the best you can to draw a nice curved shape. You notice that we're actually creating some x and y intercepts that we might, for some purposes, want to find out what they are. Ooh, that looks awful. That's like one of the worst ellipses I've ever drawn. I guess I shouldn't try to talk and do that at the same time. Well, I'll forgive you if you forgive me. Is that fair? All right. Anyway, I forgot what I was saying. I guess it doesn't matter. This question also asks us for the domain and range. So let's find that. Looking at the lowest x value that I use for this graph, it's negative 1, comma, to the highest x values, 1, 2, 3, 4, 5. The range is the lowest y value, negative 1, 2, 3, 4, 5, to the highest y value used, which is 3. And that's our domain and range. Okay. Now, the next problem is actually very much what you need to focus on not learning how to do. And this is going to be like everything possible in this problem. So let me move this down so I have a full sheet here available to me. Sorry it's taking so long. Very, very slow process to move this thing far enough. Okay, so here's a question. Given this equation, 4x squared minus 16x plus 9y squared plus 54y plus 61 equals 0. All right, so you notice the standard form had that x minus h squared over r sub x squared, etc. To get it in that form, we're going to have to complete the square. And so this is kind of set up in a nice order. I would definitely get the x's together, which they have both x squared and x first together, and then the y squared and the y term, and I would move the constant to the other side. I'm not going to take a line just to move the 61 over. I'll do that as we're doing the next line. But to complete the square, the coefficient of x squared must be positive 1. So I'm going to have to factor off the 4. So the inside of the parentheses, the coefficient of x squared is positive 1. So when I factor 4 off of the linear term, it leaves minus 4x. Leave some space there for completing the square. I'm going to do the exact same idea with the y terms. The coefficient of y squared must be 1 to complete the square, so I need to factor off the the 9, so that the coefficient of y squared is positive 1. And again, leave space for completing the square. And this is where I'm going to go ahead and move that 61 to the other side. All right, so completing the square for x, half of negative 4 is negative 2. The square of negative 2 is 4. So I need to add 4 inside the parentheses to complete the square for x. But notice with the 4 out in front of the parentheses, I haven't really added 4 to the left side. I've added 4 times 4 to the left-hand side. So on this side, I'm going to have to add the exact same thing, 4 times 4. Now I'm writing this 4 times 4 and not, I'm not writing 16. This is for note-taking purposes. It's to remind you that that number is a product of two things. You have to pay attention to that. Make sure you don't just add 4 to the right side, but 4 times 4. All right, so for y, completing the square for y, half of 6 is 3. The square of 3 is 9, and so I'm going to add 9 inside the parentheses. In reality, I've added 9 times 9 to the left side, so I'm going to add 9 times 9 to the right side as well. So now that we've completed the square, we factor that, and that will factor to be x minus 2 quantity squared plus 9 times y plus 3 quantity squared. Excuse me. And that equals 36. When you do the arithmetic on the right side correctly, you should get 36. Now, the next step is it needs to be fraction plus fraction equals 1. So I'm going to divide both sides of the equation by 36. And simplify the result. 4 does go into 36 evenly, so that cancels nicely to be 9 in the denominator. Notice that that has to be a 1 times the x squared term in the numerator. You can't have a number outside the parentheses left there. So I'll talk in a minute, I hope I'll remember to do this. What do you do if it's not going into the denominator evenly? In fact, I better do that sooner rather than later, so I don't forget. Anyway, 9 goes into 36 exactly 4 times. That's 1. Let me just go off to the side here for a second and say we had a much simpler problem like 7x squared plus 3y squared equals 10. So if that's what we had, which by the way in a textbook problem you'll probably never encounter this, so it's not like it's a big deal, but I wanted you to see what to do just in case it ever comes up. And sometimes real world problems aren't pretty, and so this might actually happen with a realistic application. All right, So to make that work out correctly, this is how you need to think of that. To make that 1x squared in the numerator, I'm going to have to divide by 7 in the numerator, which means I'm going to have to divide by 7 in the denominator as well. So that becomes 10/7 plus y squared over dividing by 3 in the numerator, so I have to divide by 3 in the denominator. That becomes 10/3 equals 1. And notice these are not nice perfect squares in the denominator. And so the x radius and y radius are not pretty numbers at all. And that's going to happen in real life. But for most of the textbook problems, they're pretty kind to you. And they look more like the one we're working on the left side. All right. So now that we've found the equation in standard form, we have it in the form fraction plus fraction equals 1. We're ready to start finding the information. The directions, I believe, say write the equation in standard form. We've actually completed that. But what I'd like for us to do is to go ahead and do the full-blown problem. What I would expect you to do on a test is once you've gotten that far, identify the center. This will be at 2, -3. Identify the x radius. That's the square root of 9, which is 3. Identify the y radius. That's 2. Find c. C squared will be larger number squared minus smaller number squared. 9 minus 4 is 5. C squared is equal to 5. So c is equal to plus or minus the square root of 5. Okay. Then let's graph this, which is normally part of a problem that I would ask you to do, is the graphing part of it as well. So the center is at 2, -3. My x radius is 3, so I'm going to have to be able to go 3 to the right and 3 to the left. Oops, I forgot to plot that. 2, -3. And then the y radius is 2, so I'll need to go up 2, no problem. I'll put a 1 up here just for completion's sake. And 2 below, so 2 below that in the y direction. Okay, so from the center, the x radius is 3, so go right 3 and left 3. And the y radius is 2, so go up 2 and down 2. And draw your ellipse as best you can. Notice I didn't talk that time. Maybe I did a better job of drawing it. Looks a little bit better than the last one I did. Okay, so where are the vertices? Well, the vertices are further from the center than the other 2 points of the 4 that we did. So just looking at this, you should be able to read the vertices. We went further in the x direction, so starting at 2, -3, 3 to the right will put us at 5, -3. And starting at the center, 2, -3, and going 3 to the left will put us at -1. -3. Then the foci. Because we went in the x direction to get to the vertices, we're going to go in the exact same direction to get to the foci. In the x direction means we're going to change the x coordinate, so we're going to start at 2 and go right square root of 5 and left square root of 5, so that's plus square root of 5 and minus square root of 5. Comma, -3 won't change. And again, that expression has a plus or minus radical in it, so I do not need for you to write that as 2 separate points as far as I'm concerned. Okay. So, I think probably we're almost done with ellipses. I think we have an example. There's room on this slide, so I can just finish up the ellipses. Kind of hope it is. Gonna work. Okay, I think I have plenty of room. Good. Oh, there's the end of it, so I'm not sure I have enough room actually. Well, let's see if we can get it done. A lithotripter is based on the ellipse x squared over 36 plus y squared over 27 equals 1. And this determines how many units the kidney stone and the wave source must be placed from the center of the ellipse. So, we're supposed to determine how many units the kidney stone and the wave source must be placed from the center of the ellipse. So, that means that we need to find the foci. So, we're going to solve for c squared. It's going to be the larger number squared. 6 squared is 36, minus the smaller one squared. Square root of 27 squared is 27. Notice those are already perfect squares. You just need to subtract them here, actually. 36 minus 27 is 9. And so c is 3. And that means that the number of units the kidney stone and the wave source must be placed from the center of the ellipse. That's the value of c. It'll have to be 3 units from the center. Okay. All right. Yeah, we did fit it in. Excellent. All right, so I'm going to stop this one and we'll do hyperbolas next.